our speakers from DIMSI. We have Christophe, Pierre, and Quentin. They will start the talk. If you have any questions at the end of the session, you can ask. And also for the people who are joining us virtually, you can ask all your questions in the event platform. And I need to give you the microphone, obviously.
Thank you.
Sorry?
It's good.
Hello? Yeah.
Yeah.
Okay. So, hello to everybody. We are DIMSI. We are a French company which have two different businesses. We are first in the Cloudstack business. We provide private cloud for our clients using Cloudstack. And a second part of our business is to be a Microsoft Dynamics CRM integrator. We install, configure, and customize the application for our clients. And for needs of integration in the company of our clients, we have to use some Azure functions. We chose to use some Azure functions, which allows us to use event-driven development and to use modern integrations. Some of our clients does not choose to run on Azure because they want to be in private clouds or not public clouds. So we are working on a way to provide them Azure functions on Kubernetes running on a Cloudstack. And we also have a second part. Hello. We not show, but that is the deployment of Dynamics CRM on premises, a fully automated deployment using Jenkins. I will let the other one talk. So,
Yeah, so hello everyone, my name is... I've been working at DIMSI for 8 months now. I'm a senior developer in the company. So I work on C# and Java project, and I'm also in charge of Backroll integration in Cloudstack, which I will present you this afternoon.
Okay. So I told you about DIMSI already. We have two main sites and one other site, but main sites are in France, Paris, and Lorient, which is a small city in Brittany. We have three structures, so cloud and services, which is the part that delivers a private cloud. DIMSI Consulting, specialized in Scrum mastering. We have product owners and people like this, and business solutions, which is the part integrating Microsoft products. And then we go into business. What is Kubernetes?
So before going deeper into Azure functions, I just wanted to make a quick introduction to Kubernetes because we are using it to run our Azure function. So you may know that Kubernetes has been integrated to Cloudstack from the release 4.14. You can one-click deploy an entire cluster using Cloudstack UI. You can use automatically ACS to expose your services online, which will
use automatically IP address exposed through Apache Cloudstack. It offers a seamless integration because we are running on Cloudstack, but the major point of Kubernetes is that you can run it on any major cloud provider. But of course, we are using it on Cloudstack. Yeah, it was just a quick introduction to Cloudstack before continuing. So I think we're good. So why using Cloudstack? Well, because you can embrace DevOps methodology. You can maintain everything involving Kubernetes with YAML-based templates. You can handle easier scalability using containers and some monitoring tools to handle scalability. And also you can eliminate any cloud provider specific configuration as running on Cloudstack and Kubernetes, Kubernetes and Cloudstack, sorry, is the same as running Kubernetes on, I don't know, Microsoft Azure, AWS, and so on.
Okay.
Okay, so now let's talk about Azure Functions. So what are Azure Functions? This is a serverless solution that allow you to write less code, maintain less infrastructure, and save cost. So what does it mean? First, I will go deeper in the code side. So Azure Functions allow you to really focus on the code and to build app. So you can choose the language that you want. You don't have to learn a new language. So to build your app, you can choose C#, Java, Python, JavaScript, or whatever you like. And you can build very different kind of app. You can do, for example, web apps, API, machine learning, cloud automation, or something like that. And you can trigger your code by so many ways. I put some of them on the slide, but it's not exhaustive. But you can start a function with scheduling with cron. You can do HTTP requests, service bus, or RabbitMQ messages. With Azure provide monitoring with App Insights. So thanks to that, you can monitor your app, see if everything is gonna be okay or not, and that's a good point. Next, yeah. Now I will talk about infrastructure. Thanks to Azure, you don't have to worry about it. Everything is handled by Azure. The platform will be always up to date, and it's a scale-up, so you don't have to worry about performance issues. Azure will add or remove resources to meet the demand. Azure Function will help you to save money too, because you only will pay while Azure Function will be running. So it could be interesting. And an important other point is that you can deploy your code anywhere. So you can really focus on the code, and if you want to deploy it to Kubernetes in Azure or Kubernetes in other cloud provider, you can do it. So just focus on the code, and after you can deploy wherever you want. Why we should use the Azure function outside Azure? Well, you can get benefits from the two worlds, you know. You can get benefits from Azure function, as I presented to you, but you can use different cloud providers. So if you want to change after development of a cloud provider, you can do it. So this is really really good. You can save cost, and of course you can choose to use a favorite cloud orchestrator like Cloudstack.
So before going deeper again into Azure function, I have to introduce KEDA. So to mimic how Azure function run on Microsoft Azure, we have to use KEDA. So what is KEDA? KEDA is an event-driven autoscaler. So it is built on top of the pod autoscaler that is embedded in every Kubernetes cluster. So the main difference here is that you can count on external sources to trigger scalability of your deployments. So instead of relying on, let's say, memory or CPU metrics, you can rely on, I don't know, Kafka, Cassandra, Redis. You focus on the events that are occurring to your workflow, and then you decide to scale up, scale down your deployments accordingly to the events. So this picture is from the KEDA website. It just shows that you have scale object, which talks to Kubernetes API server. We have metrics adapter, controller, scaler into KEDA that works in parallel to the pod autoscaler embedded in Kubernetes. And so he waits for external trigger source. So what I said earlier, and then you can adapt your workload according to your needs. So right now, there's a small limitation for using it outside of Microsoft Azure. It requires to have a storage in Azure. So the storage is not for the function itself, but for the framework to handle some triggers, like I think it's cron triggers.
Cron triggers, yes.
Other cons is that, of course, Azure functions are better integrated into Azure right now, but it's an open source project, which is, of course, led by Microsoft. But, well, Microsoft is doing a leap into open source projects for the past few years now. So it's very active. You can ask anything you want to the team that manage Azure function code. And of course, you will benefit more if you are already an Azure user, because you need you may be more familiar with all the Azure terminology, Azure functions, or services included to an Azure subscription.
Okay,
that's all for me.
So now we will go into a small demo. I presented. I just developed. So let me see what I can do. Duplicate.
So what we are going to show you is deploying an Azure function right into a Kubernetes cluster that on our Cloudstack infrastructure at DIMSI.
So we can see that we are using I don't know if a framework on top of C#, which is Fluent functions, no, Fluent Monkey, which is a way to define Azure functions. So we can see that we have a function that will run every 10 minutes on a cron, and a function that will run on it's not the final code, but run on HTTP requests. The route will be /v1/else, and it will launch a command that will have a command handler this command handler will call a CRM server to know who are we. We have built a deploy.yaml file. In fact, function the function CLI built for us deploy a YAML file, which is containing every local settings. For example, we have in the sample, I will show a RabbitMQ event driven function. So we have a connection string, RabbitMQ connection string. We have a dynamic CRM connection string, Azure storage, which is the part that we cannot remove from Azure as of now, because it's if you scale out your pods for a timer trigger function, you will not want to have several functions running at the same time on the same trigger. It's good when you have lots of HTTP requests and you will want the different pods to handle each one a request. But if you have a triggered event, in a cron triggered event, you don't want two processes to run at the same time. It will not. So the storage is handled. A lock is put on the storage to say which pod is handling the cron table. Then second part is for API keys that the HTTP request will require. A service account is created, airbag roles are created, assigned, and two deployments are created, one for the part handling HTTP requests and one for the part handling, so we have an image configured. So I will apply the deploy part. So the components are created here. We can see, so I deleted them before, but we should see the pods. I'm using Visual Studio Code, and there is a Kubernetes extension that I think is quite good. So we have two pods created, one for the part that is not HTTP. So it will contain a timer trigger, event-driven like service bus, RabbitMQ, another part handling HTTP request. So if we go to, let me see. So we have a service that has been created that got an external IP address. So I will be able to make requests to this URL and have a Swagger file generated for our call. I can try to call it right inside there. So it returned the 200 response. The content of the response is here, so it will not be very. It doesn't speak for itself, but it's the response from Dynamic CRM saying we are this user and things like this. So it works exactly like it would work on Azure. Then second part of the example would be to let me see, is the port forwarding active? No. So I will port forward RabbitMQ. We have a RabbitMQ pod running on the Kubernetes server, but I need to access the management console to send a message to this queue. I will see the logs from our function app pod. So we can see that it detected the timer triggered function, and we have the 5 next occurrences in the log. Then if I go to RabbitMQ management console, which is I went with port forwarding, I can send the message and it should arrive, okay, up. It should arrive just in the log. So yes, we have a message saying executing RabbitMQ function, queue triggered function, welcome to CCC from DIMSI, for DIMSI. So every trigger we tried worked perfectly in Kubernetes. Maybe the next steps would be to have a magnifique error, because the timer trigger is I didn't develop it, and it's not the method is not implemented exception. So every 10 minutes it will make a not implemented exception, but it ran on the schedule. Fired at 9:20. It will fire next at 9:30. The next step would be for HTTP Azure functions to have a specific domain name, because for now it's only IP address. But I think with cluster IP or load balancer, I'm not a specialist of Cloudstack, so I know. You say ingress? Was it ingress with?
You can use some load balancer. Like traffic, Azure proxy to execute multiple Azure functions on the same public IP. But for for a brief demo, we used to use the cluster IP exposition.
Sorry. Okay. So
just to conclude, why we showed you Azure functions running on Kubernetes, we think that going into multi-cloud strategy is the way to go now. You can use Cloudstack, for example, to make some development environments to pay less. Then when you're ready, you can launch, I don't know if you want to launch Azure function on Azure, on AWS, everything that can handle a Kubernetes cluster, you can make it. So that's why that's the point of our demo today. So yeah, if you have any question, we will be happy to answer.
No.
Thank you, first of all. Second, this was pretty high level for me because I'm not a coder. But what got my attention was the fact that the Azure functions, open sources, they are still tied into the Azure public cloud, which seems not quite right. Is there any way or any sort of plan to completely decouple the functions from the Microsoft infrastructure?
I think the project is not closed to the idea of separate completely. The only link that is still existing is, as I said, the locks that is put when you have a timer trigger function. If you don't use timer trigger function, you should be able to be completely separated from Azure, from public cloud. The developer team is not close to the idea of getting rid of this part. I think we have to show them that it's in their advantage that we use Azure functions, but on other cloud providers, and they will see the need to remove this link.
Do you have something else to ask, Bhushan? Okay. Any other questions?
To what extent are your clients going to be able to supply the functions?
We are supplying the functions to them. We are it's our role as a Dynamics integrator to create the functions, but currently we create them, and we rely only on Azure. So the clients need to have an Azure subscription, need to pay Azure fees, and we want to switch. For example, as Quentin said, for development environments, for things like this, and to minimize the costs for the clients. Still using Azure functions because we are integrating Microsoft products, and it's really easy with Azure function to integrate with the Dynamics. So we chose this technology for this. But if we can reduce the cost for the customer and still get a full experience, it will be great.
Thank you. Anybody else with questions? Here you go.
Hi. So first of all, thank you, Christophe. I think this is the first time your demo is working when you are making it public. So congratulations. Only one question. You mentioned business case where you want the development infrastructure in Cloudstack, and maybe production in AWS or any Cloudstack provider or Azure. I don't know. Is there a way? I think it's for Quentin. It's more a DevOps question. Is there a way to define YAML or pipelines to deploy development branch directly to your Cloudstack environment and separate deployment for production or a UAT or whatever? Is it something available, or is it complex to do?
No, you can definitely do it. I mean, CI/CD are completely customizable, so you can make a branch pipeline to deploy to AWS, a pipeline to Cloudstack on a private cloud to Azure. It's just a matter of CI/CD configuration. Pipeline creation and configuration.
So there is nothing inside the code. It's just the deployments, the pipelines you have to configure.
The YAML file will be the same across
okay.
all deployments, with some minor changes, like maybe namespace or to expose your service using.
Yeah, the source code itself is exactly the same for all
everywhere. It will just be Kubernetes related configurations that may change depending on your cloud provider. But definitely you can.
Okay, thank you, Quentin.
Anybody else? Okay, so let's give applause to the DIMSI team.